Yeah, this textbook is definitely a lot more personable, I think.
Yeah, I like him a lot. I realized that I put that in the wrong spot. Are we out of space on this one? Oh, we're kind of out of space. Whatever, let's start in here. All right, so let's talk 2.3, number 13. Okay, so we're supposed to explain facts. All right. So if the third column of a matrix B is all zero, the third column of the product EB is all zero for any matrix E. Okay. So explain facts is maybe slightly different than prove, but what the hell? Let's think about this as though we were going to prove it at least. A proof is just a really good explanation, basically.
That's basically what my dilemma was. Like, I can prove it, I just don't know how to explain it.
Okay, so let's see if we can explain it first. So E times B is E times, let's see, I guess columns of B, right? Do I
Mhm.
know how many columns B has? Is that in evidence here?
At least three.
Yeah, good. At least three. No idea. So I know it's B1, right, for the first column, and B2 for the second column. And oh, and this one is easy because I know that one's the zero vector, right? And then B4, maybe, and kind of on out to Bn.
Mhm.
And like these ones like may or may not exist. Are you with me on that?
Mhm.
Okay. Um, Probably a more robust mathematical notation would be to say that this is kind of dot 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 to Bn, and that way it's the sort of dot 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 says there may be these, we don't know. You guys kind of with me on that? All right. So next thing next, how do I actually do that multiplication? You get a new matrix, right? And remember, the way that you multiply a matrix by another matrix is you just do this outside matrix to each column, right? So I'm going to have EB1 is my first column of EB, and EB2 is the second column, and E times the zero vector is my third column, and then some stuff happens, and then I have EBN as my last column. You guys all good with that? So really this boils down to the idea of like, I need to figure out what E times the zero vector is. Yeah. So what's a matrix times the zero vector? Okay. So um, really this amounts to me needing to answer this question. Right? E times the zero vector is something, right? Okay. So what do you want to do? Column picture or row picture?
Column.
Okay, cool. So column picture would tell me that let's see. So all the entries in the zero vector are the zero or are the scalar zero, right? So this would tell me I have a matrix E that has columns like E1. This is crappy notation, but whatever. E2 up to E, I don't know, M, I guess. You guys with me on that? And then I'm multiplying this by the zero vector. So the column multiplication picture would tell me that I have 0 times the first column plus 0 times the second column plus 0 times the third column. and on out to 0 times the mth column, whatever that one is. You guys see that? Okay, so what do you get when you multiply 0 by a vector?
Zero.
You get the 0 vector. So this is the 0 vector here, right? This guy, 0 vector. This guy, 0 vector. This guy, 0 vector. This guy, 0 vector. Right, so this is the 0 vector added together. So what this tells me is that this is like a little claim, right? Let me do this. Let me just scoot all this crap down a little bit. So I'm making a little claim here. And the little claim I'm making here is E times the 0 vector is the 0 vector for any matrix E. You guys see that? And so I'm saying this is the column multiplication picture. And then this is 0 times a vector is 0. Right? And then this one is maybe the 0 vector plus the 0 vector is the 0 vector. Applied a bunch of times. So this thing amounts to kind of at least a sketch of a proof of this. You guys with me on that? I think maybe some nice concise phrasing would really help there. But for right now, I'm just giving a sketch. You guys all... Do any of you have questions about how to turn this sketch of a proof into a more robust proof? Okay. Hearing no complaints, I'm going to assume that you can do that. Okay. So what I've found here is essentially that their claim, right, this fact. So if the third column of B is 0, the third column of EB is all 0. So I would say that's because, right, my explanation would be writing the following down. E times the third column of B is the third column of EB. And E times the 0 vector is the 0 vector. So the third column will have all zeros in it because it is the 0 vector. Does that kind of logic make sense? And then the proof is just writing that down while citing the specific claims. Right? So you cite the column multiplication picture. You cite the this little claim that we just made about the 0 vector. You guys all on board with that? Okay, now the other thing is a little different. So the second half of this problem is if the third row of B is all 0, the third row of EB might not be 0. What the heck is that about? First, do you even believe that shit? So here's the thing about proof, right? Sometimes you don't believe the claim. You shouldn't. You should be a skeptic. It's a terrible place to live in the world to never believe anything, but it also means that you don't get fooled very often. So let's not believe this. Let me see if I can find a matrix that has zeros in a row where I can multiply it by something and get not zeros. You guys with me on that? Okay, so let's do it. Let's see if we can find one. I just want to find B with third row 0, but and I guess and an E. Rephrase what I'm trying to find here. And an E, I guess, so that EB third row isn't 0. You guys with me on this? All right, so first let me make a B with a third row of 0. I'm going to make the kind of easiest B that I can think of to start with. I'm not sure this is going to work, so I'm just going to make the easiest B I can think of. Okay, I started with a matrix. Does this matrix have the property that its third row is all 0? Yes? No? The third row? All zeros? Guys, the suspense is killing me here. Is the third row of this matrix all zeros?
No.
No! This was an abject failure. We have to do better. How do we make the third row all zeros?
Make the last one a 0.
Yeah, get rid of that guy. You guys with me on this? So now I have a matrix with a row of all zeros. And I guess I get to construct this matrix E. So I just want to multiply this thing by something on this side. Right? So that I get something that doesn't have a row of zeros, well, specifically so that the third row isn't 0. You guys all see that? Okay, so I'm just going to start again here with the identity matrix. This is a crap idea. It doesn't work. Right? You guys see this? Why didn't this work? Thoughts? What's my problem here? This ain't going to work, because this is just going to leave this alone, right? You guys see that? It's just the identity matrix. It's not going to do anything to this. So I need something else. So I'm reminded that there were those elimination matrices before, right? So I want to put something not 0 in that bottom row. Well, I know that I could get it by like adding this row to that bottom. You guys see that? So I think if I made a matrix here that did add row 2 to row 3, I could have the property I wanted. So I'm going to erase the 2, 3 entry, and I'm going to put a 1 there. You guys see this? Did I lose you all? Does it seem like I've gone on a real wander? I'm not sure where you guys are at right now.
No, I'm fine with this.
Okay, so now if I actually do this multiplication, right? I'm going to take... How do I actually do multiplication? You guys remember? Well, I designed this thing to be an elimination matrix, right? So it should be super easy. That's kind of why I did this, was to make one that I could kind of manipulate in my brain, right? So I'm going to get out of this. Well, my elimination matrix was designed to leave row 1 and 2 alone, right? So I have row 1 and row 2 left alone. What's going to happen to row 3, though?
It's going to be 0, 1, 1.
Yeah, it's going to be 0, 1. Well, it's going to be 0, 1, 0. You guys see that?
Oh, yeah, because the 0. Yeah.
So one thing I knew, right, from the first fact was that this column of zeros wasn't going to go away. You guys see that? And I know that I'm not going to be able to get away from having a singular matrix. Right? It's still going to be singular. Like, there's no way I can get out of that. But I do know that I can get that third row to not have zeros in it, right? So when they ask if the third row is all 0, the third row of EB might not be 0. Well, that's because it might be a linear sum of the first 2 rows. You guys see that? So if all the rows aren't 0, I can definitely exhibit a matrix that's going to give me rows that aren't 0. Because the elimination matrices can mess with rows. You guys all see that? Okay, cool. I'm going to assume you're all good on that, hearing nothing. All right, so to kind of more carefully summarize 2.313. So let me maybe make a little bit of extra space here. Okay, so essentially my first fact boils down to if the third column of B is all 0, then the third column of EB is all 0. So in order to kind of write a careful proof, I'm going to need to kind of outline the things I need to know. So let's see.
We did that first part. We kind of already.
Yeah, so I was, yeah. Okay, so your question wasn't about how to write down the first part, it was how to write down the second part?
Well, yeah, because we already, you already said the part about the first part.
Okay, cool. So in order to write down the third part, we made this example, right? So I'm supposed to explain the fact if the third row of B is all 0, then the third row of EB might not be 0. And the way I would explain that fact is consider the matrix B is 1, 0, 0, 0, 1, 0, 0, 0, 0. And I guess I need to matrices. B is this, and E is my elimination matrix that I constructed. Right? So then I can say, all right, so we're considering these, then EB is, and we give our solution for EB. So EB is 1, 0, 0, 0, 1, 0, 0, 1, 0. Right, so this is not strictly speaking an explanation. This is an example, or a kind of a counterexample, right? So I would then say, okay, so the third row of EB is not 0, or is not all 0. In this case, because an elimination matrix, or maybe an elimination inspired matrix, can add a row to our third row, and I suppose I should specify a non-zero row. to our third row of all zeros. And then I might make an even further claim here. Oops, shit, my OneNote locked up on me. That's probably good. So my further claim would be that, in fact, if I have a matrix B that isn't exactly the zero matrix, then I can construct an elimination-inspired matrix in much the same way that's going to populate the matrix EB with all non-zero rows. Does that make sense?
Mm-hmm.
And I might spend a minute and construct that that kind of thought, but since OneNote locked up, I'm not going to get to have to.
Yeah, I pretty much have to go now anyway. But
Okay.
yeah, thank you.